Hey, AP Computer Science. Welcome to day 4 of our unit. And today we're going to talk about interfaces. So we're going to start with a little lecture, and then we'll do a code along where we develop a set of classes with interfaces to understand what we're doing. So as a warm-up, this would be a lot easier if we were in class together, where I'd cut out the words and you'd move them around on your desk. But I have, 12 words here. And what I'd like you to do is take a moment and group them or organize them as best as you can. So put them in piles together. So go ahead and pause the video and give that a go for like a minute and then continue the video from there. Don't forget to pause the video and try. Don't just keep going. Okay, here come my answers. So the first thing that some people do is they will often group it like mammal, bird, and fish, right? They get the 3 big categories, and then they'll say, okay, mammals can typically walk, birds can typically fly, and fish can typically swim. And then they group things accordingly. Okay, cows and dolphins are mammals, penguins and robins are birds, bluefish and batfish. We don't know what batfish are, but they have the word fish in them, so they probably are fish. So we'll put them over in the fish category. And this is all lovely, except then we're like, oh, wait. But dolphins don't swim. I mean, don't walk. They swim. And penguins swim and walk, but they don't fly. So penguins do 2 things, right? And batfish kind of walk. You can Google them, look them up. They kind of walk on the ocean floor. So our first grouping doesn't really work. So then the second way some folks will often group these is they'd say, okay, let's go with what they do. So walk, fly, and swim. So things that walk are penguins and batfish and cows, and robins fly, and dolphins and bluefish swim. Okay, well, that's all well and good, but I have no idea where to put mammal, bird, and fish now because they're all mixed up. And penguins can still walk and swim, but I only put them under walk because I can really only group them in one category. So this is a programming challenge that we run into all the time. So before we keep going, let's just back up to what we did yesterday. And let's just talk about inheritance again. So again, every time we create a class, we specify its parent. And if we don't specify a parent, we get the object class as our parent. And a class inherits all the behaviors and attributes of its parent, right? That's the beautiful thing. And we can declare things of abstract that can't be instantiated. So basically means that we're defining or declaring methods, but we're not actually providing implementation. And those are abstract methods. And we saw that yesterday when we were working on the bouncer, or reviewing the bouncer. So some of the key elements here is we have the extends keyword, right? That tells us which class we're extending. And if it's missing, again, we extend the superclass of object. And all Java classes extend from the class object at some point in their hierarchy. So again, recalling our review yesterday, we have like circle sprite and rectangle sprite. Both of those inherit from the class sprite, right? They both have the move and constructor from sprite. And the really cool thing is the bouncing panel only knows about sprites. It doesn't know anything about circle sprites and rectangle sprites. So that's a big reason why we do this inheritance, right? So we can group things together at this higher level, call them all sprites, but then they can have special personality as well. And that's what circle sprite and rectangle sprite do. So let's bring us back to our challenge of today. Is a bat a mammal or a bird? Well, if you ask your biology teacher, they'll say, of course it's a mammal because it has hair and it feeds its young and so forth. But our challenge as programmers is it shares many of the behaviors of birds, right? It can fly. So in Java, or in all programming languages, this is called multiple inheritance. We want to inherit from 2 different things at once. But in Java, we have strict single inheritance where every class is exactly one superclass. But we can get around this. Java gave us a convention to get around this by giving us interfaces. So a class only has one superclass, has exactly one superclass, but it can have as many interfaces as it wants. So let's think about what the Java hierarchy might look like. So we might create a top-level abstract class called a vertebrae, animals with backbones. And then we could create some more abstract classes that refer to types, categories of vertebrates, fish, birds, and mammals. And these are all abstract classes. I'm going to move me over here for now. And then we can keep going. And then we could create actual classes for each of these, right? So bluefish and batfish are fish, robins and penguins are birds, and so forth. So those are actually classes. But then what do these classes do? Well, then we can create interfaces. So we could create a swimming animal interface, and bluefish, penguins, and dolphins all would implement that. And then we could have a robin, which can fly. And then we could have animals that walk, again, batfish, penguins, and cows. And the beautiful thing here is, like, penguins can implement both, right? So they can have two implementations. But then the other ones, they don't need to be, their interfaces are not tied into their actual abstract classes. So you can kind of have two different senses of hierarchies here. So what is a Java interface? We've seen this before, but let's just review again. So it's declared just like a class, but it describes behaviors only, right? It doesn't have any fields or data, and an interface cannot be instantiated. So only objects can be instantiated, and that's a critical one. So what we're going to do now is a little code along, and we're going to build all these different things and try to develop that understanding. So let's open up our IntelliJ. So we'll switch over to IntelliJ. Get started up, code along with me. I created a day 4 package. And so inside here, I'm going to create a vertebrae class. So let's do vertebrae.java. Oh, sorry. Okay, inside here, we're just going to give it a silly method, but a good method. So all vertebraes will have this nice thing called celebrate life. And all they're going to do in there in life. And they'll just go in and they'll just print yay. So sout. Okay, it's good to be alive. So we'll put that in. And then we can put in a toString. So public string toString. And let's return I have a spine. Or technically, I think they might go for backbone. It'd be good to look up. I don't know if there's a difference between spine and backbone. And we're going to make this abstract. So I change it from public class to abstract class. It can be a public abstract class. But let's just make it abstract. And we're going to cheat here for a minute. We're not going to. We could create different files for each of the following, but it'd be a lot of files, and just more than we need at this point. You're allowed to put multiple classes in one file. You just can't have more than one public class in the file. So we're going to cheat at this point. So now we're going to say abstract class, and we'll do bird, and we'll say extends vertebrae. And then in here, we're just going to give it a toString. And so our return. And let's do the superclass toString. And then let's add some more in here. So we'll do plus. I have feathers, wings, and eggs. Perfect. Actually, I'm going to go back up to the toString of my superclass and just get rid of that period. So now, basically, when I print out a bird, it'll say I have a backbone plus I have feather, wings, and eggs. And then let's do one more. So let's do public class mammal and extends vertebrae. And we'll do the same thing. You could return just super. You don't need to put actually toString there. It will assume that you're calling the toString if you're putting it into a string, but that's okay. Plus I have hair. So the mammal has hair and fur, and nurse is young. And those are mammals. Perfect. So now we have our top level classes. Did I spell mammal wrong? I spelled mammal wrong. Let's put an A in there. Okay, so now we have our 3 abstract classes from our drawing. We won't bother with fish. And then we can also then create our interface. So instead of the word class here, we're going to put interface. And we'll just say swimming animal. And what do swimming animals do? Well, they swim. So anything that's a swimming animal, it will have a public void swim method. And that swim method can do anything we want, but we're just saying anything that's a swimming animal can swim. And likewise, let's create a flying and a walking animal. So let's do a flying animal. And we'll do walking. So go ahead and finish those up, and then we'll go on to the next part. So again, what we did is we created 3 abstract classes. The top level vertebrae, that's our root abstract class. Then we create a bird and mammal, which descend from vertebrae or extend it. And then we created our 3 interfaces that are going to define behaviors that specific animals can do. Okay, continuing on, let's create some objects now. So we're going to create a cow to start with. And a cow is a mammal. And it also can walk. So this is how we're going to, so it extends mammal, everything extends exactly 1, and then you can implement as many things if you want. And so we're going to do a toString, just like we've been doing for all these, public string toString. And for this one, it'll just return these cow. I'm a cow, comma, and let's do plus super. That's what we're talking about before. We don't actually need to put the toString there. It will call the toString for us. Oh, I lied. You need to put in the toString. Okay, and then the second part, this is showing an error right now, and it's going to say, hey, since you're implementing walking animal, you are required to have this method called walk. So if you're not going to implement it, you either need to declare yourself abstract or you need to implement it. So let's go ahead and implement it. So we are required to have public void walk, and we can do whatever we want in there. And so we'll just say cow walking. By the way, it should be toString open close paren. Several mistakes here, I apologize. Okay, so our cow is done. Just go back and check the toString. I had to make a couple corrections. And then we did walk. Let's do another one. Let's do penguin. So penguin extends a bird, but it implements walking animal and swimming animal. So again, so you extend exactly one thing, but you can implement multiple things. So let's do our toString, public string toString, and we'll do the same thing that we just did before. So we'll return I'm a penguin, and then we'll just do plus super.toString. So basically the same thing as cow. Apparently with super you need to use the .toString. And then again, we'll see an error that we need to have both walk, and if we fix walk, then we also need to have swim. So we'll do public void walk, and we can just say penguin walking. And we'll still have an error because we need to implement swim, so we'll do public void swim, and we can do penguin swimming. So we have just one more to do. Now let's do a dolphin. So we'll do a cow, which can walk, a penguin, which can do both, and then a dolphin that can only swim. So last one, let's do dolphin. So that's a mammal, but it implements swimming animal. Perfect. So same pattern. So public string toString. And we'll return I'm a dolphin. And then again, we need to implement this swim. And just say dolphin swimming. Okay, so we finished our classes. The last thing we're going to do is a little demonstration of how these can be used in a program. Okay, let's create a farm. So we're going to create one more class, create your farm. And inside this farm, just create your main. And let's create each of the animals. So we'll create cow, cow C equals new cow. And we'll create a, what else? A penguin. Penguin P equals new penguin. And then finally a dolphin. Oh, let's do a mammal. So this is interesting. This is like our warm-ups. We can create a dolphin. And since it's a mammal, we can do that. And actually, let's do one other thing. Let's do a walking animal, W, and we can assign the cow to it. So you can create variables of interface type and assign objects to it that implement that. I could not assign, say, mammal to this, because not all mammals are walking, right? So a dolphin particularly does not walk. So it only can be objects that actually implement it. Okay, so then, interestingly, I can create an array list of type vertebrae. And we'll just do verts, those new array list. We have to do some imports. And we can add all of these to it. So I can do verts.add, and I can add C, I can add P, and I can add M. Right, so a beautiful thing about inheritance or polymorphism is I can add these all to the same because a vertebrae is the common root of all these things. And then I could also create an array list of walkers. So I'll just create a second one, but it'll be of the walker and a walking animal type. And we'll say walkers. And so for walkers, just like we did higher, we could say walkers.add, and we can add the cow to it. And we can do walkers.add and add the penguin to it, because that walks. But if I tried to add a mammal to it, it would not work, because not all mammals are walkers. We could, let's just print these out. So we could do for vertebrae v in verts. And we just print them out. Out, and we'll print out v. And now print out all of our vertebrae using our toStrings. And for each of these, we could also do v.celebrateLife, because they are all vertebrae. They all have that method that was defined at the highest level. And you could also do the same thing for walkers. So that's it. The key here is the concept that you can create a variable of the type of the interface, and you can assign things to it that implement that interface. You can, just in the same way, you can create array lists that work with those. Oh, and actually, let's do some walking. We could then do c.walk, right? We could do p.swim. We can do p.walk as well. And we could do, what can a mammal do? Mammal doesn't actually have any of those, right? Mammals can celebrate life. But we could do a cast, right? Because when we created the mammal, it was a dolphin. So we could cast, do a cast dolphin, put an M in there, surround that guy again, and then just do dot, and then we could swim. Because we know that guy can swim, so we can go for it. So if you run this, you'll get some nice output. I'll pause this while I run it. And here's the output that you would have if you ran it. So hopefully you typed this all in. All this code is also in Code from Class, so you can check it out as well. So that's it. I will talk to you soon.